Hello, ladies and gentlemen. Today we're going to be going over linear versus nonlinear functions. So linear functions have a constant rate of change, and nonlinear functions have a variable rate of change, or the change is not the same. So when we're looking at it in a table of values, we find the rate of change for x and y, and then we make sure that they're the same for x and y. So for example, if I'm going from -3 to 0, I would add 3 there, and to go from 0 to 2, I would add 2, and to go from 2 to 5, I would add 3. Notice that this is not the same rate of change. If all of these were +3, that would be linear. And I would go over to the other side and do the same thing. To get from 1 to 16, we add 15. To get from 16 to 26, we add 10. And to get from 26 up to 41 is going to be 15 again. So this one is also not linear, because if all of them were 15 and all of these were 3, that would be linear. But this is non-linear because they're different. Okay? So on a graph, the line is just one single straight line. This one is obviously not a one single straight line, so this is non-linear. Then when you're dealing with variables, the x has an exponent of 1. It's just plain old x and plain old y. So this one just has plain old x and plain old y. So this is linear. Okay. Examples of nonlinear equations would be like x to the second, y to the second, the square root of x, and the absolute value of x. Oh, okay. So I'm going to write that last problem down. So this is linear. And then, so we had x squared, y squared, the square root of x, and the absolute value of x were my examples. Okay, so let's look at number 1 on these bottom problems. So number 1, to get from -4 to -2, we would add 2. To get from -2 to 0, we would add 2. To get from 0 to 4, we would add 4. As soon as I get to that different value, it's nonlinear. I don't have to go any further. Okay. Then on number 2, it's just plain old x and plain old y. There's no exponents or anything like that. So this is linear. Okay. On the contrary, I'm going to jump to number 4. Notice that the x has an exponent of 2. This is nonlinear. Okay. Then we're going to jump back up to number 3. That's a curved line. That is not a straight line. So this is nonlinear. And then number 5 is just one single straight line. So that's linear. And then for number 6, we got to find our rate of change. To get from 1 to 2, we add 1. 2 to 3, we add 1. 3 to 4, we also add 1. So far, so good. Then to get from 2 to 4, we add 2. To get from 4 to 8, we add 4. So therefore, it's not linear. It's non-linear. Okay. If this continued with +2 all the way down the y, that would have been considered linear. But that one was not non-linear. Thanks so much for watching, and I hope you have a great day. Bye-bye.